Hello everyone, this is homework 2. Now, in homework 2, we are given a static memory and we're gonna use that memory for our operations. And the static memory needs to be used for multiple matrices. So we are going to implement matrices, but we are going to use the memory to store the matrix, its data and its size. The following are given. We have a defined statement named mat capacity, so matrix capacity, so how many matrices we can fit into this memory. And then we have the mat size len for the row and col limit. So this is basically, let's say this is 5, so we can store 5 matrices. And the size len is, for example, 10, so it means that at max we can use 10 by 10 matrices and 5 of them. So that kind of is what these two definitions are for. Our matrices have float data type, and the whole memory is going to be represented with this float mem array here. And we will have also a mat count that represents the matrix count. If we add matrix, this will go up 1, so this is basically a counter. And these are given, and I again have the code structure for you, so don't panic, you will have the structured code. So you are asked to implement the following functions. The memdump function, which prints the whole memory as it is to the console for debugging purposes. So this will be worth 15 points. And then there's a mat dump, which is basically the same as memdump, but instead of dumping the whole memory into the console as a whole memory, it will show it matrix by matrix. So we can examine what matrices are in the memory. So basically mat dump is, these both functions are kind of print functions, but you have to access the memory, show what the whole memory is made of, or you have to show matrix by matrix what is stored in this memory. And then we have mat push, which, as you might expect, adds a matrix to the memory. So we will give the m by n size of the matrix, we will provide the data of the matrix, and we will push it to the memory, so it will check if the memory is empty, place it to the first place. If there's, for example, if the capacity is full, it should check it, then it cannot enter, or it cannot basically add it to the memory. So that whole checking stuff is needed here as it is written down. So if the capacity is full, of course you cannot add it. So this is kind of a calculator stuff again, but a matrix calculator sort of. We will add matrices to the memory if the capacity is not full. So then there will be a mat pop. We remove the last added matrix from the memory and place zeros instead of that, so we can flush the memory. So we basically place zeros into the place of the old matrix so that there's no residue from that, so there's no data that doesn't make sense. Normally if you use for example C, don't initialize it, you see some silly numbers that are stored in the memory, so we want to wipe out the memory with zeros or refresh the memory with zeros. And then we have a mat add and mat subtract, which both are basically the same. Add the last two matrices, so it will just add the existing last two matrices to each other, remove both of them, and place the result. So basically if you have an addition or subtraction, then you will end up losing one capacity of matrix here, or one matrix, because it will add the last two matrices or subtract them, remove both the matrices, and then place just the result as a matrix into this memory here. Now again, everything will be implemented in a single file, and you will again submit a single file here. The given main function should not be submitted, only the student file here. And let me show it to you. I have again this basic structure here. Here's this main file. In this main file we have memdump, matdump, matpush, matpop, matadd, matsubtract. These are the functions. Here is a test code, so you can just have an example to understand it better. For example, we have a 2x2 matrix. We're pushing a 2x2 matrix, and the values are 2, 2, 2, 2. So that's basically it. And then we add another matrix here, again 2x2, 1, 2, 3, 4. We dump the memory, we subtract, and then we dump the memory in matrices. And we're going to see what the output is. And here are the functions that you should implement. Again, you will not submit this file on the right, you will only submit the file on the left. And here are some definitions. The mat cap, which was the matrix capacity, at the moment this is 2, but you can change it up to 4, 5. So the thing is that the code should be generic. So that is basically the limitation here. You should use these defined statements. So if you are going to use the matrix capacity, use this mat cap here, define variable. If you are looking for the mat size limit, then you should use this, as it is done here during the definition here. Because these are constant definitions, you can do that. You can say, this is the whole memory that I need. By the way, we are storing the sizes. So, yeah. If we have, for example, a matrix size limit of 2, it doesn't mean that we are going to store a 2x2 matrix. It could be a 2x1 matrix, it could be a 1x2 matrix. So everything is possible in this case. The maximum would be 2x2. So it could be a smaller one. Here I assume that if we put in matrices, since we will call add and subtract here, they should be compatible in size. So we are always adding with the same size. And but if we do it, for example, like 4x1 and 4x1, everything should still work. In this code especially, I have put in 2x2, 2x2, but it could be 4x1, it could be 1x4. It should work as expected. So that's important. I'm not going to push a matrix or a vector and then try to add them. You don't really have to check that. Even though we can, I'm going to skip that part, so it's kind of easier for you to implement it. Don't worry about that. We will use this generic type only for example, increasing the matrix capacity up to 10 or maybe 100, and then the limit is 5. We will work with 5x5 matrices, 10 of them, and do stuff about this. So I didn't also include the multiplication or determinant or trace or whatsoever. So it is just the basic thing that you should get here, nothing else. So it's it could have been worse, but it's not really that bad if you think about it. The only thing is that we will have the size stored here. You have to store it in the memory, because once you push this whole thing, everything else is gone and vanished. You will not know what the size is, you will not know anything else in these functions here. You only push once. So the strategy here is to basically store m and n and then the whole data. So for example, m, n, and then data 0, data 1, etc., etc. So each matrix is kind of needs to be stored kind of like this, if you want to store the matrix. Or of course it could be also at the end, and I'm going to show what my version is, and you should stick to that, of course. Now you should basically implement it here, only in implementations where it is said so, and don't change anything else. You might want to change the values of these here and nothing else. Hope that that's understood. Now in terms of output of this specific given thing here, we can see that here we go. Now 2, 2, 2, 2. This is basically our first matrix here in the memory. And then we have 1, 2, 3, 4. This part is the second one. And the size, m by n, is appended at the end. So basically data comes first and then sizes are appended. So for one matrix that is that has only 4 elements in this case, which is a 2x2, we have 1, 2, 3, 4. The whole data here. So this is data 4. So this is 2, 2, 2 added in here. And then we add m and n. So number of rows, number of columns. So again here that's the same. And then when we call push, we add them to the memory. When we call memdump, we can see that the whole memory is just one line thing. You can just stick with that. The whole memory is printed using a for loop, and yeah, everything what is in it is shown. That's basically it. In matrix dump, but you can see that that's not the case. We have just one matrix, and the reason for that is after memdump we subtracted the matrices, so we have the result here. 2, 2, 2, 2 minus 1, 2, 3, 4 should give us 1, 0, minus 1, minus 2. The subtraction is done, and if I call matdump, I get this here. Well, you can play around with this once you have, of course, implemented it, but let me recap. We have certain definitions which are given here. You can change them in order to toy around here, but the actual thing is that the important stuff is that it should basically do the job that is intended to do. We will store the data, and then the m, or the number of rows, number of columns, and yeah, other than that, when we're printing it like a matrix, we are basically using the whole thing there. So matdump needs to know what the size of this is. Memdump doesn't. Memdump just prints out what this float thing here stores. Everything is shown here in memdump, but in matdump it is going to be printed like matrices. And if I have, for example, 3 matrices in it, it should show me in matdump, it should show me them with their size, matrix 1, matrix 2, matrix 3, etc., etc. I need to be able to push. I'm going to store m and n and the whole data. I need to be able to pop, which is just deleting it, wiping it out. It should decrease the counter, it should set the memory to 0. You get the whole idea, and additional subtractions also needed to be implemented. And if I run this code, it should give us this result. Hope that everything is clear, and let me again remind you that you only have to submit this file here and nothing else, so that's important, and good luck.